Hi, I'm Shota Yamanaka from Yahoo Japan Research. In this study, we investigated the user performance on goal crossing operations where users have to avoid touching destructors. LASS operations are used to select multiple objects in illustration software, note-taking tools, and presentation tools. When users draw a stroke through a gate between objects, they have to carefully move the stylus to avoid touching these objects. In such tasks, we have demonstrated that the gate passing time follows the crossing model, that is, Fitts law. In conventional crossing tasks, users cross the start line and then cross the end line. The movement time has a linear relationship to the index of difficulty ID. However, if there is an obstacle that users have to avoid, the movement distance increases. Thus, we hypothesize that the movement time increases when an obstacle intrudes into the direct path for this crossing movement. A modified Fitts law model is needed to predict the movement time more accurately. In experiment 1, we tested the effect of obstacle intrusion distance OI on movement time. When the OI is 0 or negative, the participants just have to draw a straight line, but when the OI is positive, they have to draw a curved stroke. 12 participants joined in the study, and we tested 3 target distances, 2 target sizes, and 4 obstacle intrusion distances. In our results, the movement time increased with the OI because the path length increased. Therefore, a modified two-step model showed a better fit than the baseline model of Fitts law. Interestingly, the movement time difference was significant even when the obstacle didn't intrude into the path. To investigate this effect in more detail, the OI values were negative or 0 in experiment 2. This means that intentional avoidance of the destructor was unnecessary in all conditions. We hypothesize that even when a destructor doesn't intrude into the crossing path, the OI will significantly affect the movement time. The results showed that the participants clearly made curved strokes to avoid the destructor, although the destructor was away from the crossing path. The effect of OI on the movement time was significant, but the difference was not large, at most 39 milliseconds. Therefore, adding the OI term didn't improve the prediction accuracy relative to the baseline, the Fitts law model. We also investigated the effect of the destructor length on movement time. The length is defined as the ratio of the movement distance A. We hypothesize that even when a destructor doesn't intrude into the crossing path, the length of the destructor can affect the movement time. Our results show that the participants made curved strokes when there was a destructor. The effect of length on the movement time was significant, but the effect of length was again not large, at most 101 milliseconds. Therefore, the fitness improvement through adding a length term was not significant. In summary, from the result of experiment 1, if obstacle avoidance is necessary, we need a modified model to predict the movement time more accurately. In contrast, if the obstacle avoidance is unnecessary, the movement time increases, but a modified model is not needed. So, even if users perform unnecessary obstacle avoidance, the movement time can be predicted by the baseline models through Fitts law. This helps in the design of experiments and UIs because we can use the simplest model. For example, when researchers evaluate new interfaces, such as attribute gates, they can estimate the potential decrease in task difficulty for a given task condition. In conclusion, we have investigated the effects of necessary and unnecessary obstacle avoidance behaviors on user performance in crossing operations. Avoiding the selection of unintended targets is a common requirement in our daily computer work, but as researchers have focused mainly on target selection, there are no quantitative models. We believe that our work is a basis for future contributions to the HI field, such as deriving refined models and designing user experiments. Thank you for watching.